The second part of section 4.3, we're now going to look at the point-slope form of a line. So when we're given an equation in this form, we have some similarities, but some things that, a little more confusing. The equation obviously looks a little more detailed, but for the most part, it just gives us specific information, and it's not too bad to deal with if you know what each piece means. So just like in slope-intercept form, the m letter in the basic equation still represents the slope. That's still going to tell us how to move from point to point. Y and x still appear in the equation, and those are always going to remain in the equation as y and x. However, the y1 and the x1 that are in this form of an equation, those happen to be the coordinates of any given point on your line. So this is a useful form when you maybe know the slope and that one point. You could instantly go and write an equation in this point-slope form. Whereas if you want it in slope-intercept form, it might take a little bit of manipulating to get it into that form. One thing to take note of, though, you always start this form of the equation with subtraction here and here. Now, if the coordinates end up being negative, that changes some things, as we'll see, but it always starts as subtraction. And it doesn't matter, again, what point it is, as long as you know one point on the line, any point, then you can use this equation, this form, the point-slope form of an equation. So our first example here asks us to find the equation of a line with slope 1/3, and that also happens to pass through the point -6, 5. So our slope of 1/3, this tells us a specific part of our equation, that's the m value. -6, 5, that tells us one point on the line, so we can call our x-coordinate -6, that's going to be our x1, and then our y-coordinate 5, that's going to be our y1 when we actually write this equation. So those three pieces of information is all we need in order to write an equation in point-slope form. We need to know our y1, our x1, and our m, and we have those three now. So let's start writing in this form. Y minus the y-coordinate, so y minus our y-coordinate, which is 5, equals m. Our m value, our slope, is 1/3. That's going to go out in front of this parenthesis here. Parenthesis x minus x1, the x-coordinate. So inside the parenthesis we're going to have x minus our x-coordinate, also happens to be negative here. So we're going to have x minus a -6. So initially it would look like this. So like I said, you always start the equation with subtraction, both here and here. Now you're going to have to clean that up a little bit if you have subtraction followed by a negative. So to get this actually in point-slope form so it doesn't look as, I guess as doesn't have too extra operations, we can rewrite this as y minus 5, that's going to stay as y minus 5 equals 1/3, comma, remember whenever you subtract a negative, it's the same as saying addition. So x minus -6 would be the same thing as saying x plus 6. And that right there then is the equation in point-slope form. And if you're asked to give the equation in point-slope form, you're done. That's all we would need to do. Pretty simple, if that is the case. Just again, keep in mind, it always starts as subtraction. The actual form, like it's given up here, the general form has subtraction. But when you're given your answers, if your coordinate happened to be negative, it's going to turn it to addition when you give the equation for a specific line. So if the coordinate is given as positive, it's going to be subtraction in the problem, or in your answer. If the coordinate is given as a negative, it's going to be addition in your answer. Okay? So that's point-slope form. But then let's say you were asked to give that same equation, but they want it in standard form. If you recall from section 4.1, standard form is when we have an equation in the form ax plus by equals c. So the x and y terms on the same side, and the c values, whatever number is by itself, that doesn't have a variable attached to it, that needs to be by itself on the right-hand side. So how we do this? Let me rewrite the equation we have above in point slope form. Y minus 5 equals 1/3 comma x plus 6. So there's our point slope form. Now in order to get this into standard form, we can't have this parenthesis. So first step, take the 1/3 out in front of the parenthesis, a hidden implied multiplication in between the 1/3 and that parenthesis, so we can distribute the 1/3 to both the x and the 6. Little review over here to the side. Well, 1/3 times x is just going to give us 1/3 x, but 1/3 times 6, in case you need to do this, fraction times a whole number, we could always turn a whole number into a fraction by putting it over 1, so 1/3 times 6 over 1. When we multiply that across and across, we get 6 over 3. 6 divided by 3 will reduce to a whole number 2. So rewriting this equation, that now that we've distributed the 1/3, we have y minus 5 equals 1/3, 1/3 times x gives us 1/3 x, and then the 1/3 times 6 gives us a positive 2. Alright, that's still not in standard form. We don't have x and y on the same side. We don't have the non-x and y terms, in other words, the whole numbers on the other side and combined. So we can do that next. Let's get this minus 5 over to the right hand side of the equation. Doing the opposite of subtracting 5 would be adding 5, and that would cancel out the 5's here. But whatever we do on the one side of the equation, we have to do the other, so we have to add 5 onto the right hand side of that equation as well. So it cancels out the 5's on the left and gives us what we want on the right of 7. So 1/3 x plus 7. Okay? We're almost there now. Technically right now we're in slope-intercept form. So if you're asked to put it in slope-intercept form, you'd be done right there. However, that's not what we were asked. We were asked to put it into standard form. We need x and y terms on the same side. So in order to do this, we can do that in one step by bringing the x term to the left. So it's a positive 1/3 x. To cancel that out, to get rid of it, we must subtract 1/3 x from both sides. So subtracting 1/3 x from both sides, it's going to cancel it out here, leaving just the 7 on the right hand side. And on the left hand side we have our x and y terms together then. So let me bring this over here. Typically we put the x term first, so a negative 1/3 x. That's a positive y, so plus y. And it's a positive 7 on the right hand side, equals 7. So that right there would be your answer in standard form. And that's really all you need to know for section 4.3. Next video we'll look at the end of this page, which is section 4.4, and we're going to be graphing a linear inequality rather than just an equation.